Welcome. Today we shall be looking at differentiation of functions of a function. Before we go into working some examples, let me take the time to explain what is meant by the functions of a function. Let's take for instance that we have cos x. Now cos x, the value of cos x depends on the value of x. For instance, if x is equal to 0, cos x will be equal to 1. And if x is equal to 90, cos x will be equal to 0. So we can say that the value of cos x depends on what the value of x is. So in that case, we can say that cos x is a function of x. Let's look at something a little bit more complex. Say we have cos x squared plus 3x. This implies that the value of cos x squared plus 3x is a function of what x squared plus 3x is. So the value of x squared cos x squared plus 3x depends on what the value of x squared plus 3x is. So it's the function of x squared plus 3x. Take note of that. I said the value depends on what the value of x squared plus 3x is. The value of cos x squared plus 3x depends on what the value of x squared plus 3x is. Now, let us also remember that x squared plus 3x is a function of x. Yes, x squared plus 3x is a function of x, because whatever the value of x squared plus 3x is depends on what the value of x is. So if x is equal to 0, x squared plus 3x will be equal to 0, meaning that cos 0 will be equal to 1. So we can see that cos x squared plus 3x depends on what the value of the value of x squared plus 3x is, and then x squared plus 3x in turn depends on what the value of x is. So we can say that x squared plus 3x depends on what the value of x is, and in that case we could call this a function of a function. So we can say that cos x squared plus 3x is a function of x, and that is what we refer to as functions of function. Okay, let's go into working some examples. Say we have differentiate with respect to x, y is equal to cos 4x plus 5. Y is equal to cos 4x plus 5. Now, before we go into solving this example, I would like us to take down the following, this formula. The y dx is equal to the y du times du dx. Okay, let's note that down, please. So how do we go about differentiating something like this, a function of a function? What we'll do first, let's put u to be equal to 4x plus 5. U should be equal to 4x plus 5. Therefore, that expression above becomes y is equal to cos u. Y is equal to cos u. Remember, we said let u be, because we've already said u should be equal to 4x plus 5. So y now will be equal to cos u. Okay, based on our formula, we said dy dx is equal to dy du times du dx. So let's try to get all these terms that we can put into the formula and then get what dy dx is. So the first thing we need is dy du. So what is dy du? Dy du is going to be equal to, we differentiate cos u with respect to u. We differentiate cos u with respect to u. Remember our fourth law. We said cos dy dx of cos x is equal to minus sine x. So dy du of cos u is going to be minus sine u. Easy, right? Okay, so we've gotten the y du. The next thing we need is du dx. So let's remember that we said we are making u to be equal to 4x plus y. So now we are going to be differentiating with respect to x. That is, we're going to be looking for du dx. If u is equal to 4x plus 5, it means that du dx will be equal to what? 4. Right? Based on our second law, du dx will be equal to 4. You know, when we differentiate this, 4x, if x is the same thing as x to the power 1, so based on our second law, if we use the coefficient of x to multiply, if you use the power of x to multiply the coefficient of x, that's 1 times 4 is 4, and then 1 minus 1 is 0. Anything to the power 0 is 1. Our first law says the differentiation of a constant is equal to 0. So the differentiation of 5 is equal to du dx for 5 is equal to 0. In this case, we have du dx will be equal to 4. Okay, so now that we have that, we can then bring the terms together based on our formula. We said dy dx is equal to dy du times du dx. So dy du is minus sine u, and then du dx is 4. So in that case, if we multiply the two of them together, we would have minus 4. Dy dx is equal to minus 4 sine u. Remember, we said u is equal to 4x plus 5. So we can bring that back. We can replace 4x plus 5 with u. So that dy dx now will be equal to minus 4 sine 4x plus 5. Very easy. Okay, let's work on another example again. Let's look at another example. Say we have that y is equal to exponential sine x. Exponential sine x. This is another function of a function. The exponential in itself, just like cos, is a function raising another function, sine x. So based on our formula, let's still remember the formula that we had before. We are going to look for dy dx. That dy dx is equal to dy du times du dx. That same formula applies here. So the same thing again. We say let u be equal to sine x. What we do is we look at this thing like an onion that we are peeling from the inside. So we have a function raising another function. So this is where we have this is like the inner function. Sine x is like our inner function. So we're going to be putting that inner function as u. So we say let u be equal to sine x. Therefore, y will be equal to exponential. You got that right? U. Y will be equal to exponential u. And then based on one of the laws that we gave initially, please go through the rules of differentiation that we had done initially. You would see those rules there. We have that dy du, differentiating with respect to u, exponential u is the same thing as exponential u. Remember, we said dy dx exponential x is equal to exponential x. So dy du of exponential u is the same thing as exponential u. Okay. Then we need next thing we need is du dx. We've already said that du dx u is equal to sine x. So du dx will be equal to what is the differentiation of sine? That is cos, to give us cos. So du dx will be equal to cos x. Du dx is going to be equal to cos x. Now, we can bring all the terms together. It will now become dy dx will be equal to multiply dy du time by multiply dy du by du dx. So dy du is exponential u and du dx is exponential x. So du dx is cos x. So that would be equal to exponential sine x times cos x. Exponential sine x times cos x. And this will be equal to dy dx now will be equal to cos x exponential sine x. Cos x exponential sine x. Remember what we did here. Dy dx is supposed to be the same thing as exponential u times cos x, but we've just replaced u with what it initially was, which is sine x. So that's why we have exponential sine x times cos x, which gives us cos x exponential sine x. That's easy. So let's look at something a little bit more different. Say we have y is equal to 5x plus 4 all squared. Now we're going to be using two methods to solve this, and any one that you feel is easier you can use. To solve this, I don't want to use the formula again to solve it. I want to use a shortcut to solve this. What do? I said we should look at, when you want to differentiate functions of a function, you should look at it like an onion that has different layers, and then you are working from the inner layer. You are peeling the onion from the inner layer. Not normally you want to peel onion, you peel it from the outside, but in this case we're peeling it from the inside. So what do? How do we get dy dx here? Simple. Dy dx is going to be equal to, now we can see that the first function, the outer function, is our exponential, our power, which is raised to power 2. The inner function is 5x plus 4. So the first thing I will do is to differentiate 5x plus 4. And in differentiating that, we know based on our first and second law, the second rule of differentiation, differentiating 5x plus 4, dy dx of 5x plus 4 is equal to 5. So write down 5 times, write it times. Now we differentiate with respect to the outside, and still based on our second rule, we said if you are differentiating something with respect to that has a power, we would subtract 1 from the power and then use that power first to multiply the coefficient of x. So in this case, we'll just bring 2 down, before the bracket, easy to multiply everything in the bracket, and then subtract 1 from 2. So in that case, that will be 5 times 2 into bracket 5x plus 4 raised to power, or bracket close, raised to power 2 minus 1. That's what I was just trying to explain. So we'll take this power down and subtract 1 from the power. So now we can simplify this. Dy dx is now going to be equal to 10 into bracket 5x plus 4 QED. That's the answer. You can see that we've just solved this in 2 steps. We've solved this in 2 steps. This other time we're trying to show working. So this is a shortcut to differentiating functions of a function. Now let's look at the second method of doing this. Method 2. Taking a look at y is equal to 5x plus 4 all squared, we can see that 5x plus 4 all squared is an example of a binomial equation. And based on binomial theorem, we have that if we have a plus b all squared, it is the same thing as a squared plus 2ab plus b squared. A squared plus 2ab plus b squared. Therefore, 5x plus 4 all squared is the same thing as 25x squared plus 40x plus 16. 25x squared plus 40x plus 16. How do we come about that? Remember that we have 5x. So 5x squared is the same thing as 25x squared. 2ab, that's 2 times 5x times 4. 5 times 4 is 20, times 2 is 40. That's 40x. Plus 4 squared, 16. So that is how we came about this, using this formula above. So y now will be equal to 25x squared plus 40x plus 16. So dy dx, with differentiating that with respect to x, we have dy dx will be equal to differentiate 25x squared. That will give us, we'll bring down the 2. 2 times 25 is 50, and that will be 50x. Plus, differentiating 40x will give us 40. So that will be 50x plus 40. So the y dx will be equal to 50x plus 40. Of course, if you differentiate a constant, we'll get 0. So we can do away with that. Looking at this particular equation, the y dx is equal to 50x plus 40, we can see that something is common there, so we can simplify. So dy dx will be equal to, I can bring out 10. If I factor out 10, I will have 10 into brackets 5x plus 4, bracket closed. So we can see that this answer is the same thing with what we got earlier.